Hello everyone, it's Mr. Spinelli. Today we're going to talk about finding the volume of prisms and cylinders. But first things first, we're going to practice on classifying. So the question is, what is a prism and what is a cylinder? And what other name do we add to those words? So the key thing you want to recognize is whether or not things have one or two bases. Now, what is a base? We'll kind of look at some examples to get an idea of what that means. So in this first one in the top left, I see that there's this big rectangle on the top and a big rectangle on the bottom. So because there's two of the same shape that are parallel to each other, two bases, this is going to be a prism. Prisms you want to think of almost as just a box. If it looks like a box, it's probably a prism. So this first one is what we call a rectangular prism. The rectangular part means that the base is rectangular in shape. If we look at the next one, it is also a rectangular prism. It might be square because if you look at these bases on the top and bottom, since this is kind of oriented up and down, it almost looks like that could be a square. Since I'm not certain, I'm just going to be more general and call it a rectangular prism. Now the next one, you see that it's got this triangular shape on the bottom, but then everything comes to meet at a point. So this is actually what we call a pyramid. And this one doesn't quite look like the pyramids of Egypt because it's only got three sides or three faces that are upright. So this is actually a triangular pyramid. Whereas this one in the bottom middle is a rectangular or potentially square pyramid because this base here at the bottom has four sides, whereas the one up in the top right only has three sides. So prism, you've got two bases that are parallel to each other. Pyramids, you've only got one base, and then everything comes to a single point. Now this one in the bottom left again has two bases. There's a circle at the top, and there's a circular shape at the bottom that we can't see. This would be like a prism, but it's actually a cylinder. So you could call it a cylinder, or you maybe would call it a circular prism, because technically it is a prism as well. Now the last one probably looks to most people to be a cube, and I would agree. But it's probably more, to be more general, it's a rectangular or square prism, because again it's got two bases parallel to each other, and then those sides are connected. So then real quick, we see here we've got another pyramid in the top left, and it's got a rectangular or square base. Down here in the middle, we've got another triangular pyramid. And then this one in the top middle also looks like a pyramid, except its base is circular. So you could maybe call it a circular pyramid, or you could call it a cone. Think of your classic ice cream cone. And then the remaining ones are all just oddly shaped or normal shaped boxes, if you will. This one just has a triangular base, so it's a triangular prism. This one is also a triangular base, but these are both oriented differently. This one you might say is on its side, and this one is standing up because its bases are at the top and bottom, whereas this one we're on two sides. This is in the front and then the back. And then this last one is just your classic box or rectangular prism. So let's talk about how we find the volume of these cylinders and prisms. So the volume of a prism, all you need to do is multiply the area of the base. Okay, now the base is whatever is parallel to something else. So in this case, we've got this weird shaped thing. We would need to find the area of it. Now that area is just all the space in here. Now we probably can't find the area exactly, given our tools of me with a pen and on an iPad. But if we could find the area of that base, we would then multiply by the height. And the height is given by the perpendicular distance between those two bases. So if we've got, for example, this box down here, you'd find the area of this front-facing rectangular, which should be the same as the area of this, and then multiply by the height, which is just the length or distance between those two bases. So let's take a look at the formula for volume of a cylinder. It's the same exact thing. Area of the base which is here and here, multiplied by the height or distance between those two bases. But in the case of a cylinder, you know that the base is a circle, and that circle has some radius r, so then the area of that base is simply r squared h. So you can have a more specific formula for volume of a cylinder. So let's take a look at some examples. So the first thing I want to notice is that it looks like I've got two triangles, which are going to serve as my bases, and then those are connected by some line that has a length of 7.5, which is going to be my height. So then I need to find the area of this triangle. So in order to do that, I need to remember my formula for area. So area of a triangle is base times height divided by 2. Now when I say base, I'm talking about the base length of a triangle. I'm not talking about the base of a solid, and that can be confusing. So I'm going to do 2 times 4 divided by 2, and I end up with just 4 centimeters squared. So then to find my volume, I do the area of my base times the height. So I'm going to do 4 centimeters squared multiplied by 7.5 centimeters. So when I do that in my calculator, I should get 30. So I get 30, but then my units are cubed. So I get 30 centimeters cubed. So volume is a three-dimensional quantity. It represents how much space or is contained within a solid. You can think about how much gas could I fill in this or how much water. And those units are cubed because it's three-dimensional. It's no longer two-dimensional like area. Let's take a look at another. All right, it looks like I've got another prism. And I look and I see I've got 6 walls to this prism, which means my base is a 6-sided figure, which is a sixgon. You could call it a sixgon, or you may know it as a hexagon. So I need to find the area of this hexagon. Well, I know the area of a regular polygon is simply the apothem times the perimeter, or the side length times the number of sides divided by 2. So what is my apothem? Well, it's 13. That's right here. There's my apothem. Now what's my side length? That's 15. And it's got 6 sides. So 15 times 6 gives me the perimeter. And then I divide that result by 2. So I'm going to do 13 times 15 times 6. And then I'm going to divide that result by 2. And I should get 585. And those units would be squared because it's the area of the base. And that gets multiplied by the height. And remember, the height is the distance between my two bases, which is going to be my 34. So then ultimately, my volume is my area of my base times height. So that's going to be 585 times 34. And when I type that in my calculator, I get 19,890, which is squared. Sorry, cubed. Remember, volume is cubed. Let's try some more. All right, so now I've got two bases again. So this is a prism, but more specifically, it's a cylinder. And my formula for a cylinder is area of the base times height, which is really just pi r squared h. So my h here is 80. My radius I don't have. I actually have my diameter. So I've got to take my diameter of 58 and divide that result by 2 to get that my radius is actually 29. So to find my volume, I'm going to do pi times 29 squared times 80. And when I type that in my calculator, I end up with 67,280 pi centimeters cubed. Now if I actually multiply out by pi, I end up with 211,366.35 centimeters cubed rounded to the nearest hundredth. So either one of these would be acceptable answers for my volume. The one on top, though, is exact. Let's take a look at another. All right, this one. This one is a classic box, which is a prism. So I notice I've got this square face here, because I've got my congruency marks, so I know all those sides are 4, which given the parallel nature of these two bases, all those sides are going to be 4 as well. So the area of this base is simply 4 squared, or 16 inches squared. Remember, the area of a square is just that side length squared. And then I have to multiply by the length or the height of this box. This is kind of turned on its side. So I'm going to do volume equals A times H, which is simply 16 times 9 is 144 inches cubed. Now, something you might see with boxes, prisms, I like to call these one boxes because these are your classic box. You can also just find your volume by multiplying length times width times height. And who cares what you call length, width, and height? You're just multiplying the length of all three of those distinct sides. And that would give you 144 as well. Alright, now we got a little bit of a different one. We've got another hexagonal prism. We've got a 6-sided figure on top, and that is also on the bottom. So the key here is to figure out what the height is. How far are those two hexagonal bases? They're 3 feet apart. So there's my H. So I need to find the area of this hexagon, which again is going to be the apothem times the side length times the number of sides divided by 2. So the apothem is 3.5, the side length is 4, the number of sides is 6, and I divide that result by 2. So 3.5 times 4 times 6 divided by 2 in my calculator gives me 42 feet squared. So then to find the volume, I multiply the area of that hexagon times the height, so 42 times 3, which gives me 126 feet cubed. So again, area of the base times the height gives me the volume of my hexagonal prism. Here I have another prism, but more specifically, the circular base makes it a cylinder. So I've got two circles separated by a length of 10, so my height is 10. Volume is area times the height, which is pi r squared for this particular area times the height. So my volume is going to be pi times radius is 7 here, times my height of 10. So I'm going to get exactly 490 pi centimeters cubed, which if I type in my calculator 490 pi, or 490 times pi, I get approximately 1,539.38 centimeters cubed. Alright. Oh, the gods have been kind to me. They've given me the area of my base. They've told me that I have some base here, which is the same as the base parallel to it, and that area is 150, and the height is 13, the distance between those two bases, so my volume is simply 150 times 13, and when I type that in my calculator, I get 1,950 inches. Inches, not inches. Inches cubed. So when they give you the area, that's very generous. Oh, but the classic backwards one. They've told me the volume is 144 pi centimeters cubed, the radius is 3, and I need to find the height. So I'm going to start by writing my equation. I know the volume of a cylinder is area of the base times height, more specifically pi r squared h. I'm going to replace what I know. I know that the volume, V, is 144 pi. I know that the radius is 3. I do not know the height. That is what I want to find. So now I've got to do algebra to solve for h. So I'm going to divide both sides by pi. So then I get 144 equals 3 squared h. 3 squared is just 9. So then I'm going to do 144 divided by 9, and I'm going to get 16. So I get 16 centimeters is my height. I hope you enjoyed this video. Thank you for watching and have a wonderful day.